Okay, thank you everyone for your patience. This brings us to our third presentation of the finalists. Michael Harrison and Jan-Benedict Steenkamp are going to talk about squaring the circle at USAA using a new machine learning recommendation system. So I'd like you to welcome them to the stage. Thank you very much.
Thank you, John. So as John said, Michael and I will be talking about our work with USAA, where we developed a new machine learning algorithm to better predict the preferences of the members of USAA in their automobile purchases. In our presentation, we will be joined by Robert Lagudis, who is Executive Director Enterprise Application Development at USAA. He will at the end provide a broader perspective on how this initiative has affected USAA, but he will first start and give the context in which our work has been conducted. So thank you, Robert.
Thank you, JB. Okay, so let's frame the context of what we were seeing. We're noticing a trend where USAA members were spending more and more on their automobile purchases. This was leading to some additional trends that we noticed around increases in consumer credit card debt, increases in delinquency on loans, consumer loans, and then also increases in the write-offs that the organization was having to take because of those delinquencies. And so it became clear to us we had an opportunity to be better advisors to our members, to our customers. And we also had an opportunity to better balance the needs of the individual and the needs of the organization as well. Our directive was also clear that we needed to reduce our customer automobile spending and maintain revenue neutrality while we did that. So a little bit about who we are as an organization. So for those of you who are not familiar with USAA, we were founded in 1922 by 25 Army officers. In San Antonio, Texas, we started with 1 employee, and it was an auto insurance exchange. Fast forward to about 100 years now, and we now have more than 12.5 million members. We have actually more than 30,000 employees, and we're a full financial products and services organization. So from an insurance standpoint, everything from auto, home, life, to investment vehicles, banking products and services, and advice. So as an organization that serves members, we are not a publicly traded organization. We are owned by our members. When we have profits, we share those profits via dividends with our membership. And so you see here from our brand promise, we go above for those that have gone beyond. This is in service to our members. From a military standpoint, they serve our country, we want to serve them, and we want to serve their families well. And to that end, we want to make sure that we are providing those products and services that help them achieve their own financial security. So I want to focus, and I think what you'll see across this presentation this morning, this brand pillar in the middle, financial strength and wisdom, is going to be highlighted in what we talk about. All right, so we had a model in place for our auto purchasing, our auto buying service that was pretty good at auto types. Where it didn't focus was drilling down into specific makes and models of vehicles. And when we scaled the use of the model beyond hundreds or thousands of transactions into millions of transactions, we saw run times increasing. We saw the ability to predict what the member needed was also decreasing, which led to the members going out on their own and self-directing their automobile purchase. This led to decreased customer satisfaction. So we engaged Michael Harrison and his team of data scientists to help us realize what are some of the options, what's the art of the possibility to solve this problem. Michael?
Okay, thank you, Robert. So in addition to a new recommendation system that would rectify many of the shortcomings that Robert mentioned, we focused on two key requirements and two key challenges. First, we had to process tens of millions of transactions quickly. And second, we needed to make instantaneous recommendations. So USAA defines instantaneous recommendations as those made to a customer's web session within half a second to 2-second threshold. So these requirements are important because there are two pieces that are of primary interest to the firm. First, the more and the faster we can actually process real-time data updates, the more insight we can gain into customer automobile preferences, and the better our recommendations become. And second, because we're trying to modify automobile purchase behavior to nudge customers into purchasing automobiles that are at lower prices that also meet their wants and needs and preferences, we need to take advantage of real-time data and to make sure that we have the recommendations that are the most relevant and that also meet the most recent customer preferences. So when we looked at developing a recommendation system, we researched what had been done in the past in marketing literature. So many of the existing recommendation systems and marketing were econometric. And while these are very powerful, but when we actually implemented in our environment with the number of transactions that we had to deal with, they were only able to process hundreds or thousands of records in a period of time that we needed to actually push our recommendations to a browser. So they fell short of the tens of millions of transactions or records that we needed to process as part of this system. And because of this, and also I guess additionally, since causality and parameter interpretation were not our primary concern, we started looking at other methods, and we considered a machine learning approach. And when we looked into these methods, we were able to process tens of millions of transactions within USAA's targeted threshold of half a second in which we push recommendations to a web session. So just to talk about some of the goals. So when we began this project, as Robert mentioned, USAA already had a recommendation system in place. And we were tasked with developing a new recommendation system that achieved the following goals. It had high predictive accuracy without customer input. USAA management felt that it was really important that we do not ask customers questions about their preferences because they felt it signaled to them that we did not necessarily understand their wants and needs. They also felt that if we had to ask customers questions, that we weren't taking advantage of the massive amount of data that we have available at our disposal. Our second goal was to lower customer expenditures on automobile purchases, and this is directly related to increasing financial security, customer financial security. We also had a goal of maintaining a minimum amount of customer satisfaction. So as you can imagine, if we were to ask customers to spend less money on automobiles, they may not be as happy with the automobiles available at those prices. So we had the goal of making sure this did not happen. And lastly, we had a goal of being revenue neutral on all automobile loans and automobile insurance policies. So before I discuss some of the details of how our algorithm learns, which is the piece that I'm going to focus on, and how it deals with customer automobile preferences, how it makes real-time updates, I want to first provide a conceptual overview of the entire algorithm. So what we have is, what you're looking at here is basically our algorithm. And our algorithm, the algorithm that drives our recommendation system is an iterative algorithm. So it runs about every 90 seconds. And it runs every 90 seconds so it can take advantage of all incoming streams of transactional and clickstream data. So I just want to talk about each of these stages briefly before I move on to the two stages that I'm going to focus on in detail. So in the first stage, we identify vehicles to be replaced. This is important to the algorithm because over 90% of all car sales are to replace an existing vehicle. So it's important that we understand what are the preferences and attributes of that vehicle to be replaced to serve as our reference point for future recommendations. In the second stage, we assign customers to segments. So in our testing, we found that if we group customers together by their auto preferences and make recommendations against a specific segment, we can produce much better results than we can if we make recommendations to the individual customers. In stage 3, we actually make the recommendations to customers, and in this stage, we also tally up all the recommendations that we make to a customer within his or her respective cluster, and we rank these by frequency count. And then we take the recommendations that are made to an individual cluster and we pass them to our fourth stage, in which we personalize these recommendations based on specific customer needs and requirements that are above and beyond what we've actually pushed through in the stage 2 when we created these specific segments. In the fifth stage, we identify similar vehicles. So it's important for us to identify a stream of vehicles, a queue of vehicles essentially, that we have ready at our disposal when customers decide to search for vehicles. We don't necessarily know how many they're going to search for, so we need a queue of these lined up. In stage 6, we update recommendations based on our clickstream data. And really what we're doing is we're taking into account the real-time searching behavior of customers, and we use this to update recommendations that a customer has not seen yet, as well as we pass this same data back into our stage 2, which helps us further refine our customer to segment memberships. Now, I first just want to talk a little bit about learning customer automobile preferences. And while there are many details of our recommendation system to discuss, in the interest of time, we're going to focus on those areas which we feel are the most important and directly related to customer automobile preferences and how we update recommendations in real time, as we feel these are the most interesting. So kind of what we're going to talk about here is we're going to first discuss the real-time updates of the customer automobile search, and this is our clickstream data that we capture when customers are using the car buying platform. And then we're going to go into detail in terms of the customer segmentation, which deals with infinitesimal changes in customer transaction data. So what we're looking at here is the component or the piece of our algorithm that deals with streaming customer behavioral data. So now we'll discuss how real-time updates are used before we delve into how they feed back into the dynamic segmentation piece to provide better and higher recommendation quality. So the clickstream data that we capture consists of over 200 automobile attributes and characteristics, which we use to filter automobile preferences. We take a collaborative approach to real-time updates, which we consider the aggregate of all customers within their respective segments. And we use this approach of updating automobile preferences with clickstream data because we found that it helps us better filter out noise from customers who click on vehicles such as Ferraris and Lamborghinis and McLarens and things that may be interesting, but they're not necessarily going to focus on or purchase. And lastly, you may notice that the network that you see behind me in the presentation slide. So one of the things, instead of actually storing our data in tables which have rows and columns, we actually store our data with nodes and edges. And the reason that we do this is it provides a much faster ability to query and produce traversals that enable real-time updates with content filtering techniques. So now that we've gone over the updating piece, I want to talk a little bit about the dynamic segmentation stage. And in this stage, we define segments of customers who are very similar only in their automobile preferences. So the better we can segment customers, the better our recommendations are. So to segment customers, we use a variant of a k-means algorithm with a gap statistic so that we have an automated procedure that decides the optimal number of segments with each iteration of the algorithm. So as I previously stated, the algorithm runs about every 90 seconds. So with each iteration, the number of segments can possibly change, as could the membership of a specific customer to his or her segment. And as these segments runs, with every iteration, of course, we better learn how to group customers into a specific segment based on their preferences. And that's why the continual looping of the algorithm is so important. So another piece is that when we look at the data that we're processing, we have about 4 terabytes of data that we consider in this algorithm. And in this step, we have a requirement to process tens of millions of transactions or records that are ingested into an event hub. And we use this event hub to basically produce data pipelines and data streaming out to a variety of sources so that we can queue that data available in such a way that we can call it on demand. Now, our event hub queues data from a variety of sources. So we have social media data, which we have social listening devices that are looking for automobile preferences. We also have credit card transactions, ACH transactions, which we are mining for automobile preferences. And we also have geospatial data, which we utilize to see how customers drive and to what they're actually doing. We have lifestyle data that we use to understand what are the activities that customers engage in to see if that has any impact on the types of recommendations we would make. We also use vehicle history data to elicit any specific stylistic preferences that customers may have in terms of automobiles. And then we also use household dynamics to understand who's going to be riding in a vehicle and what types of capacity and seating things we need to consider. And lastly, we look at income and wealth so that we can make sure that we recommend vehicles that are within USAA's specified affordability range. So that's just some of the basic things that we have in terms of our data that's being pushed in. And now I want to just talk a little bit about the automobile purchases. So as we all know, automobile purchases are infrequent and they're complex decisions. And it's very difficult to predict these particular types of preferences. So we take a data-driven approach that capitalizes on large volumes of data that are specifically engineered to provide insight into the preferences of customers. We also consider the variation that exists between customers who we feel are very similar, and we use this variation along with real-time explicit clickstream data to further update the preferences of specific customers. So meeting these requirements is something that's quite difficult, especially when you're trying to make sure that you can meet all these requirements, but also at a lower price. So as you would imagine, meeting these specific automobile requirements is something that we did by offering members and customers pre-owned vehicles, which is one of the directions we took. So at this time, I'd like to hand the floor over to Professor Steenkamp, who will discuss the impact of our recommendation system on the firm as well as its customers.
Thank you, Michael. Before looking at the effect of the algorithm on customer and firm outcomes, let me talk a little bit about where we are at this moment. What Michael just has discussed is a machine learning system which is among the first generation of machine learning algorithms in marketing. It uses both unsupervised and supervised learning, and it dynamically learns, updates the system in real time using massive amounts of data, which by itself generates a number of issues which can be addressed with machine learning techniques. Now, machine learning is at the forefront of marketing science anno 2018. 5 years ago, there was actually very little on machine learning in marketing. Probably in 5 to 10 years, it may become kind of common. If I look at the program of this marketing science conference, the one and only plenary session was about machine learning. And I counted over 20 sessions in the conference that was dealing with machine learning in different facets. It is my firm conviction for marketing science to remain at the forefront of developments, that we push further machine learning techniques, because actually companies are hiring massive amounts of these people and they are making rapid progress. But of course, all these kind of words of mine are not particularly useful if the machine learning in general, or more specifically our algorithm, doesn't perform very well, because if it doesn't perform very well, you know, why bother? So what I'm now going to do is to evaluate the performance of the algorithm along 2 KPIs. The first KPI is customer benefits. That is, does our algorithm truly lead to improvement of the financial security of the customers? For that, we ran a randomized field experiment in which about 1,500 people were exposed to the old algorithm, randomly chosen, and a matched sample of around 1,500 people were assigned to the new algorithm. That allows us to make more definitive statements about causality and to tease out the effect per se. Second, we looked at its KPIs regarding to what does it do for USAA's firm financials. Because at the end of the day, the firm, if it is great for the customer, but the firm really suffers, then there is obviously a challenge. And for that, we compare the financial results for the firm 2016, that is the year before the algorithm was launched, versus the year 2017, the year after the algorithm was launched. Let's first look at the first KPI, customer benefits. And the first thing that we need to look at is the predictability, because as Michael already identified, that is, we need to predict the preferences of customers better than before. And Robert already mentioned that there were issues with the old algorithm which actually led to us being tasked to come up with something new. At the basic level of automobile type, like SUV or sedan or whatever, the old algorithm has a decent performance of 51%. The new algorithm has a performance of 83%, which is a lot better. But when you look at the difference in percentage points, 32 percentage points, that is substantial. They're also significant, but ultimately substantial really matters. Now let's look at the second, more challenging level. That is the automobile make, think brands. 51 brands. The old algorithm performance declines very substantially to 13%. It's still a lot better than chance, but 13% is not particularly high. The new algorithm, the decline is much smaller and is still a very respectable 71%. 71% by chance, it is 2%. Now the third level is the vehicle model. Now, ultimately, people purchase a model and not a type, rather, and not even or a make. There are 427 models in the choice set. So random chance would be about 0.2%. The old algorithm has it 10 times better, but still, to be honest, 2% is not particularly good. And our algorithm has a performance of 70%. So by chance, it has 0.2%. With our algorithm, it has 70%. The difference between the two is obviously not only significant, but also large. Now, this is about the predictive ability, but ultimately our task is predictive ability is a necessary condition, but not a sufficient condition. What about effects on financial security? So we looked at several KPIs. The first KPI is the average price that a member paid for the car. Recall what Robert said, that USAA was unhappy that people were spending too much on cars. Now, because of the NDA, we cannot provide specific dollar figures. That legal did not allow us to do that. However, if you think about the following, that the average car price in America, the car bought, is over $30,000. If you have a 19% reduction, we are talking about a number of thousands of dollars that a member has saved by using the new system versus the old system. Because remember, this is the controlled experiment. This is what was the average price a person bought randomly assigned to the old system versus randomly assigned to the new system. Now, that lower car price feeds into some other positive outcomes. That USAA has a certain band of what they call affordability. That is, in their experience, what percentage of a person's income they should spend on cars. That band, the percentage of people that bought within their affordability range increased 340% based on people that used the new algorithm. They also saved a lot of dollars on interest, which of course is related to the lower price that they had to pay. But now let's look at these three are essentially dollar savings, but they may be savings by people that could possibly afford it. Now there is another side to financial security, that's the dark side, that's default. That is people that essentially commit to obligations and then they cannot deliver on those. I'm going to look at three of these dark side things. That is the number of delinquent loans, that is loans that are in delinquency, are in default, decreased by 87%. So under the new algorithm, it was 87% lower than the people randomly assigned to the old algorithm. Average dollar amount in default declined 19%, and then finally the number of days past payment declined by 20%. That is a lead indicator for future default if you are past payment. Now, why is this important? Well, default is not good for anybody. It leads to loss of credit loss and a lot of other things. But we are talking here about 12 million members that are members of the military family. And Robert already showed earlier on, if you are part of the military family, you have served the country, one of the things that is instilled in you is to be a responsible person. Responsible person in your behavior, obviously on the battlefield, in the administration, and your personal life. So if you default on your financial obligations, well, that is about one of the most obvious indicators that there is a tension between the values and actually what is happening in your life. So for that reason, the default issue, if anything, is even more important for these members. And that's also a reason why that financial security is one of the key pillars on which the whole USAA organization is based. This is about the customer. Let's look then at the USAA firm. What are firm outcomes? For that, I'm going to look at firm sales before the intervention took place. On average, car sales increased in volume by 6.5% in the period 2012 through 2016. If anything, there is even a little bit of a leveling off in 2016. Now, what now would the increase be in 2017, assuming that there would not be a decrease? The decrease is 16.7%. So we see a steep increase in the growth rate of the car sales between 2016 and 2017. Now you may ask, might there be some rival explanations? Of course, we have shown already in the random experiment some causality, but let's look at a couple of possible rival explanations. One thing is that USAA is so enthusiastic about the new system that they marketed it much more intensively than the old system. That did not happen. They did not actually change their marketing efforts per se. Perhaps in hindsight you could say why not, but in our case actually it kind of makes our life a little easier. A second reason is perhaps car sales increased a whole lot because of a rapid increase in GDP in 2017 versus preceding years. That is not the case. There is hardly any difference in growth rate between the two periods. A third reason could be interest rates, because if interest rates are lower, that increases car sales because most cars are financed. Well, as we all know, actually, I think yesterday the Fed again increased the interest rate, that the interest rate accelerated an increase in 2017 upward, which means, if anything, it should dampen the growth in car sales rather than increase it. So these rival explanations, plausible rival explanations, cannot explain this jump. And it is fully consistent with what we find in the with the higher predictive ability and the highest customer satisfaction in our experiment. Now let's then look from car sales to the financial indicators. We find that for USAA, the revenues of the loans activities increased by 16%, and the revenues of the insurance activities increased by 17%. To give you an idea, again, we have the NDA, that is an issue sometimes with this kind of research, but think about the following. USAA is a $25 billion company. It was founded around car insurance and car loans. Car insurance, car loans is one of their biggest divisions. If we get a 16-17% increase in revenues of one of their biggest divisions, we are not talking about millions of dollars. We are talking way north of millions of dollars. Then, consistent with what we documented at the individual level experiment, we find a decrease in delinquent loans and also finally a decline in the cost of the call center. So these are a couple of things that are in terms of further nice, because delinquent loans, we won't all recoup them, they're expensive, and the cost of the call centers is also nice. So what I show here is that doing well can be combined with doing good. And now I hand it over to Robert, who will give the assessment, a more qualitative assessment, how it has impacted the USAA organization.
Thank you, JB. All right. I think you'll agree with me. These are absolutely impressive results. And as JB just kind of walked us through the KPIs that were looked at, it absolutely hit the mark from both the customer perspective and the organization perspective. Quite frankly, in my opinion, the use of machine learning, the learning model, the personalization was absolutely game-changing that Michael talked about earlier. And as a matter of fact, at the time that we implemented this, our chief data officer commented this was the first real instance of personalization and machine learning at USAA. And it has been championed internally at conferences from our frontline developers and analysts all the way up to the CEO and our executive council. So much so that it has actually been a catalyst for the growth, the expansion of our existing data science practice and machine learning at USAA from an enterprise and also from a line of business perspective. So while you may say, well, this is not rocket science, it's not. Maybe a mixture of data science and marketing science. Our use here of customer interaction and behavior data, along with open source technologies like streaming using Kafka and Cassandra and Titan and storing this big data in Hadoop, we are actually porting these type of capabilities to other USAA experiences. And I think you'll agree with me that in looking at what we've presented today, the porting options across industries and companies in the globe could potentially be endless. I'd like to thank you for your time this morning, and with that, I'd like to ask JB and Michael to come back up for any questions.
Thank you.
Good morning. This is a very fantastic case study. I'm very impressed by the engineering aspect of putting so many things together. I also am very gratified that you mentioned that this success give extra credibility to machine learning and lead to a wider adoption of this in your business. I think that's terrific. So I do have two questions. One is I found the reduction of loan default number a bit surprising. It's very high. It's a bit surprising, given the fact I don't know. I'm not expert in this subject, but I would imagine people would default in year one of the car loan, probably a certain point, depending upon your lease term. So how come that something happened in 2017, which presumably you implement the algorithm lead to an immediate loan default reduction? So that's my question number one. Question number two is really on the machine learning itself. If you think about machine learning, you talk about data, system, feature engineering, algorithm, and this whole thing, right? So what makes, in your opinion, in this process, in your opinion, what's really the sort of the driver for this success? It's because we have more data, or it's because we just have more clever feature engineering, or it's because we use non-parametric methods to make the prediction much more accurate, like comparing with what we have done in terms of the algorithm number one.
Yeah, I can definitely take number two. So I guess your question is related to what's the most interesting piece of this. I think what makes it work so well, like you elicited to feature engineering, so that's something that we spend a lot of time doing. So like when you think about like what we've actually, our data is actually engineered so that we're clustering people together based on specific automobile preferences. So it's just not like a data set of demographics, it's data that's engineered specifically to understand what car should somebody purchase. And another thing that makes this work is the algorithms, it's actually a series of algorithms, and the environment that we built as part of this is all designed for computational efficiency. So everything that we've done is designed so that we can provide lightning fast changes to data that's being streamed in from all these sources. We can queue data in such a way that we can make use of it in real time, and then we can also provide these real-time updates directly to a client's web browser when they're using the car buying platform. But I think it's that computational efficiency as well as the specific data that was engineered directly for this particular purpose.
Yeah, it was a set of data. So it was not only, say, demographics or social graphics, it was a whole set of different data about social media, about car driving, even about geolocation. And an attractive aspect here is that while K-means is generally, quite a strong clustering technique, it is not without the machine learning, let's say, adaptations that Michael and the team made. You cannot apply it to 4 terabytes of data. So it is the combination of the complexity of the data mix, which is much broader than a normal lifestyle or demographic kind of setup, and then having the specific computer learning techniques underlying that you can actually cluster that matrix in a way that cannot be done with traditional techniques.
I'll take a crack at your first question. While I'm not a financial advisor, I'm an IT and data guy. I have to imagine that our customers, our members, when they are balancing, higher debt now, and they put themselves in a position where they have to pay certain bills, the non-essentials kind of get pushed to the back, right? So there's core things like eating and where you're going to put your head at night that you want to make sure those things are paid for. transportation will kind of take back seat. So I don't have the exact explanation of why the delinquency would happen so quickly, but other than from that perspective of just prioritization.
Okay. Thank you.
Thank you again. That was really a fantastic presentation, and of course, the actual implementation was even more impressive, right? I really enjoyed listening to the talk and the details. I had two questions. One is more of a clarification question. I just did not understand how things were implemented, and I wanted a clarification question. And the second is a more substantive question. So let me start with the clarification question. You, JB, you showed us the improvement that happened in the prediction. And I wasn't entirely sure about how that implementation was measured and why, and how would you say the match was actually superior? I just did not understand it, and I would like that clarification. The second question, I think, somewhat relates to the question that was previously asked, but this notion, so I was wondering, like, you did the customer metrics using this experiment, and you did this nice comparison. And I was wondering why that same thing could not have been at least used. I understand you want to scale it up to the full firm. Why couldn't that have been used to actually understand the financial benefits of this as well? And the reason I ask that is, again, when you do cross-year comparisons, there are many reasons, of course, and you try to rule out a few explanations. But an important thing that struck me was interest rates are obviously gone up, and merely pushing people to less expensive stuff is a good idea, right? Whether you did any of the predictions or whatever, it would definitely get you a lot of the benefits that you would want. But what would be nice is to actually compare how much of the prediction actually really cost that improvement in financial metrics. And that would, I think, make the research come across even more stronger. So those were two comments.
We'll do the second question if you do the first one.
Yeah, so the first one was basically just asking about the different samples. Is that what you were talking about?
The first one was more about, you said the matching was superior, like you went from 2% to 69% in one of those things, right?
And why do I think that's the case?
And how did you actually measure it even? I was not entirely sure.
So we basically just took the old algorithm and actually ran it through a set of data, and took the new algorithm and ran it through the exact same amount of data and compared the results.
I think more specifically, because people have made a choice at some point, and we know what the system recommended. So the hit rate is whether the person purchased the car that was recommended by the system or purchased something else.
Okay.
And I can provide a little bit more.
Okay,
So there are a couple ways in which we know whether somebody purchased the vehicle. We know that they purchased the vehicle if they used the car buying application to actually make the sale. And if they did not, we'd know the recommendations that were made because we tag all of those. Another way is that if they end up using an automobile loan, then we actually know the choice that they made, and we can see that, compare that against the recommendations that were given. And the last way is whether we see that vehicle added to an insurance policy. So we have those three different ways in which we can make a determination as to what vehicles actually purchased. Because you're right, there is sometimes a lag. Somebody does searching at this point, but then 2 weeks, 2 months later, they actually buy the vehicle. But that's how we make those connections.
Then let me take the second question. So there are a few things here. First is, it is interesting when we compare the average price that a member paid in 2017, that was under the old algorithm, with the average price that a member that was randomly assigned to the old algorithm in 2017 paid, was nearly the same, which kind of is a validation about there. However, you have a very valid point. Can you not look at the old versus the new group when it comes to the effect? Our thinking was the following. The company is essentially, if I'm just brutally honest, is not interested in any random experiment. The company is interested, 2016 through 2017. So the company wanted to see information to what extent this new initiative actually led to a return on investment that was good. So from that point of view, we did the comparison between 2016 and 2017. We could also run a similar comparison on a small group. say under 1,500 people. The results, because when we look at it, so when you look at the default rates, etc., and at the company level, what you will find is that the results will be very similar, but from a company point of view, it is not something that they're really interested in. They wanted to see whether the system actually really made a difference, but ultimately for them, it was that aspect that mattered. Well, we could easily do that.
Thank you.
In that case, I'd like to thank our presenters very much for a very nice presentation. Thank you.
Thank you, John.
Good work.